All right, so I'm going to be talking about nonlinear systems and how we solve them. So first off, what is a system? So a system is when you have two or more equations that you are considering together and you're trying to find a solution that works in all of the equations that you have. We indicate that we have a system by using these curly braces surrounding the equations. And generally, they're X and Y values. So you're looking for an ordered pair. And that's a two variable system where you've got X and Y. So you generally want two equations to solve a two variable system. If you're in engineering, this is often called a simultaneous system or simultaneous equations versus just a system of equations. So nonlinear systems are specifically when the equations you're looking at are not lines. At least one of them is not linear. You could have a linear equation and a nonlinear equation. So at least one of the equations in your system is not linear, not going to form a line. So it could be quadratic, it could be a radical, it could be any sort of type of equation. These types of equations often have more than one solution because you're going to be intersecting in multiple places, especially if you've got a line going through like a parabola, it will intersect in like two different places. So the best way to solve these is usually with substitution or graphing, but there are times where elimination works really nicely. But for the most part, elimination is difficult. And so you're going to want to choose substitution or graphing. And there are certain situations where you can't solve by substitution either, and you have to solve by graphing. And we'll go over all of these. So the steps for solving by substitution, which is going to be the main method that you'll use, is that you pick one of the equations and then you solve it for one of the variables because you've got two variables. Then you plug your result into the second equation that you have and you solve this for the variable that's in there. When you do this, you're going to have an equation with one variable so you can solve. And then that will give you a number. And then you take that and you plug it back into your equation that you had from step one to get your second number. And this process is called back substitution because you're substituting it back into the other equation. And then you're going to write your final answer as an ordered pair because you've got two values, X and Y. So this is a good example of a nonlinear system. And this is one that you can solve with elimination. Because if you add your equations together, the Y and the negative Y, those will cancel. And then you have just your X pieces. But we'll solve it with substitution because that's the most common way that we solve these. So we've got 4x squared plus y equals 3. And then negative x minus y equals 11. Now you have to choose, do you want to solve for X or for Y? Generally, you want to solve for the variable that is not the nonlinear part. So you don't want to solve for X because we've got something with a squared and it's going to get messy. You want to solve for the variable that's linear, that doesn't have any exponents on it. And you want to solve the equation. Well, it doesn't matter which equation you solve. You can solve the first one or the second one, but you don't want to solve the one that has the solve for the variable with the exponent. You want to solve for the other one. So we're going to solve for y. And it's easiest to solve the first equation for y because all I need to do is subtract 4x squared from both sides. If I solve the second one, then I have a negative y when I try to solve, and I have to do a division as well. So I'm going to label these equations. We're going to have equation 1 and equation 2. And so we're going to solve equation 1 for y. And so that we have 4x squared plus y equals 3. And we are just subtracting 4x squared from both sides, which gives us y equals 3 minus 4x squared. And the order that you write that doesn't matter. So I just write it, in the order that I've got there. It really doesn't matter whether you have the negative 4x squared first or the 3. Then we're going to plug in, I'm going to call this equation 3. We're going to plug this new equation 3 into equation 2. So we have negative x minus, and then instead of y, we're replacing that with 3 minus 4x. And then that's equal to 11. So we're going to simplify this, and this is going to give us a quadratic equation because we have this x squared. And in order to solve a quadratic equation, we need everything on one side. So you have to know your procedures for solving various types of equations. I'm going to start by simplifying. We have negative x minus 3, and then it's going to be plus 4x squared equals 11. So quadratics, we have the x squared part first. So that's 4x squared. And then minus x, then minus 3 equals 11. And I need to have it equal to 0 in order to solve a quadratic. So I'm going to subtract 11 from both sides. So that gives us 4x squared minus x minus 14 equals 0. And now we need to solve this equation. So I'm just going to call this 4. So I just like to make everything numbered to help it be organized. And we're going to solve this. So we can solve by factoring or doing the quadratic formula. Sometimes these things don't factor. I'm looking to see. I don't think this is one that is going to factor. I'm trying to just kind of do this in my head, see if there's a way. I think we can make this factor. I'm going to try it. So I think if we have 4x and x equals 0, I think if I have a 7 and a 2, I want a negative 8 plus 7. So just double checking. 7 times negative 2 is negative 14. 4 times 1 is 4. And then with the insides, I have a 7x minus 8x. So that gives me negative 1. So this factors. So once you factor, you set each one equal to 0. So we have 4x plus 7 equal to 0, x minus 2 equal to 0. And then we solve. So the first one is going to subtract 7 from both sides. We get 4x equals negative 7 and x equals negative 7 over 4. And the second equation, we're going to get x equals 2. So we have two x values here, which means that when we plug this into y, we're going to get 2 y values. We're going to get 2 solutions because we have a different x that we need to plug in, and we need to plug in both of these. So these are part of our solutions, and we need to plug in our values for x into equation 3. So I will just label these. This would be 5 and 6 that we've just created are 2 solutions. So we're going to plug 5 and 6 into equation 3 so we can get the y values. One, 2, 3. Okay. So 3 was y equals 3 minus 4x squared. And we got x equals negative, we'll go 7 over 4 and x equals 2. So just writing those down. So if I plug in negative 7 over 4, I'm going to have 3 minus 4 times negative 7 over 4 squared. So this is 3 minus 4. And when you square it, you're squaring the top and the bottom, and you square negative, it's going to be positive, and that will give us 49 over 8. And that reduces to 49 over 2. The 3 I need to write as a denominator of 2, which is 6 over 2. So we have 6 over 2 minus 49 over 2. And then this gives us negative 43 over 2. So one of our ordered pairs is negative 7 over 4, negative 43 over 2. So that is one solution, assuming that I didn't make any arithmetic errors here. And I'm going to put in my calculator just to verify that I didn't make any errors with my arithmetic. I got negative 37 over 4. So where did 7 squared? Oh, because 4 squared is 16, not 8. Always check your work. So then that's going to be over 4 over 4. So this is actually needs to be 12 over 4. And then 12 minus 49, negative 37. Okay. So when you're dealing with fractions, always check your work, especially if you've, you're trying to do some of the math mentally, you may make a mistake. So if you have a calculator that does fractions like mine does, you can use that to check your work. So our first answer is, oops, and that should be over 4, not 2. So it's negative 37 over 4. Second answer we get by plugging in 2. So this is, I'm less likely to make a mistake mentally with this one. So I'm plugging 2 in for x. So we have y equals 3 minus 4 times 4, because 2 squared is 4, gives us 3 minus 12, which is negative 9. So our second ordered pair is 2 and negative 9. So I like to check my work, not only with my calculator, but to also graph it, because then you can see really what you're graphing here. So I'm going to go back to, whoops, too far. I'm going to pull up Desmos. That's what I use for all of my graphing. And I'm going to type in our system that we have here. I'm going to type in the two equations separately. 4x squared plus y equals 3, and negative x minus y equals 11. Okay, I'm going to pull this over. So I need to zoom out so we can see. So we have two intersection points between these two graphs. So this first one here is negative 1.75 and negative 9.25. So if we convert that to our fractions, that's our negative 7/4 and the negative 9.25. I hit the right button on my calculator, negative 37 over 4. So that confirms with what we solved. The second one, we got to negative 9. Did I do my math wrong again? This is 2 negative 13. I plugged into 4 times 4 is 16. Apparently I cannot do math today, and nobody is here to find my errors. So it's a Friday. Apparently I cannot do math on Fridays. Certainly not in my head. 4 times 4 is 16. 3 minus 16 is negative 13. So always good to check your work and find, oh, I can't do arithmetic in my head today, apparently. So that second point is 2 negative 13. And at least using the graph, I was able to figure out, oh, I made an error somewhere. And then I need to go back and see where in my math did I mess up. So we've got this nonlinear system because one of the equations is actually quadratic, which is a parabola. And so there's two solutions because there's two intersection points. Now, this one here is a system that you cannot solve by your methods of elimination or substitution because of the fact that we have our variable in the exponent and the variable outside of the exponent. So you haven't learned any methods for how to solve something like this. And so the only way to solve it is by graphing. So I'm going to just make sure. So because we have a variable in an exponent, and outside an exponent, we can only solve by graphing for what we know so far. If I tried to do the substitution here, it's already solved for y, so I would be replacing y with -4e to the negative x. And then you have this plus 3x plus 8 equals 0. So when you're trying to solve for x, you would have to take the natural log to get the x out of the exponent, but then you end up with this natural log of x from the 3x. And so then you've got a problem, because now to get the x out of the natural log, you have to raise it to an exponent. You basically undo what you just did. So there's no way to isolate x in both of these, because it's two different methods. You'd have to undo each other. So you can only do this by graphing. So I'm going to pull up Desmos. And so our first equation was y equals -4e. Get up to the exponent to the negative x. So that's that one. Our second one was y plus 3x plus 8 equals 0. And so this intersects in only one location here. As you can see, we've got a line, so it's only going to go through this once, because this basically doesn't have any dips or anything. So our intersection point is right here. And in order to get to the intersection point, I need to click on one of these. And then this is just an approximation. There's more decimal places to this, because e is a special number where it goes on forever. So there's more decimal points than we see, because it's irrational. But we're going to just use what we see from the graphing calculator. Our x value is -0.49, and the y value is -6.53. -0.49, -6.53. There's no other way to try to solve this without trying to do some advanced techniques. Okay, so this is my last example here, and we've got x minus 2y equals 0, 3x minus y squared equals 0. So we can solve this by substitution, and we'd want to solve for x and substitute in to the, like, maybe solve the first equation or linear equation for x, and then plug it into the second one, because we don't want to solve an equation for y, because that's where we have a y squared, and that's going to cause some problems. So I'll label these 1 and 2. So I'm going to solve equation 1 for x. So I have x minus 2y equals 0, and this gives me x equals 2y. Easy enough. And that's going to be, we're going to call that equation 3, and we're going to plug 3 into 2, the other equation that we haven't worked with yet. So that's 3 times x, so that's going to be 3 times 2y minus y squared equals 0. So 3 times 2y, we have 6y minus y squared equals 0. So this is another quadratic equation. And this one we can solve by factoring. And we like to have our negative part, the squared part in first. So that would be negative y squared plus 6y equals 0. And we're going to factor out a negative. We can factor out our greatest common factor here. And when that first term is negative, you're going to factor out that negative. So our greatest common factor is y. So we're going to factor out a negative y, which leaves us with a y minus 6, because that changes that plus 6y. We're dividing it by negative y. So now it becomes a minus 6 equals 0. So we get negative y equals 0, which just solves to y equals 0. And then y minus 6 equals 0, which gives us y equals 6, not 0. So I'm going to label these as 4 and 5. And so now we are going to plug 4 and 5 into equation 3 because that's solved for x and we need to find the x values. So we have x equals 2 times our first y, which is 0. So we have x equals 0. And then we have x equals 2 times y and use the 6. It gives us x equals 12. So your ordered pairs are 0, 0, and then 6. Nope, I got to make sure I put them in the right order. X first, 12, 6. And make sure when you're writing your ordered pairs, you're writing the right pairs that go together, the x and then the y that matches with it. And make sure that you have it in the right order, because in this case, we solve for y first and then x. And so the order that we solve for our variables was different. You need to make sure that your ordered pairs are x comma y. So let's graph these, make sure I haven't made any other math errors. So I will delete these and type in, we had x minus 2y equals 0. And then 3x minus y squared equals 0. Okay, so we can see one solution here at 0, 0. And then this one here at 12, 6. So this one, I was able to do all my math right. No errors. So those are our two solutions. So you can have nonlinear equations that are more than just quadratics. You can have cubics where you tend to have 3 solutions. You can have absolute values, you can have square roots, you can have a whole bunch of different types of nonlinear systems. Usually these are paired with a linear equation. So you'll have one linear and then one nonlinear. If you have 2 nonlinear equations, then it gets really tricky because then you need to solve one of the equations and you kind of end up with 2 equations that you then need to plug into the other one, and it sort of like doubles your answers. And so those situations, it's easier to do it by graphing. But if you've got a linear and then a non-linear, you can solve those by substitution. And that's really the best method to do it. So thank you for watching this. Unfortunately, no one was able to attend, but I hope this was helpful for you. And let me know if you have any questions or if you find any math errors. I've double checked all my answers, so my answer should be right, but maybe I wrote down something wrong. So if you find any errors, let me know so I can correct it. All right, thank you. Bye.